Assignment video presentation chapter 5. Given question, du over dt is equal to k d square u over dx square with the initial condition ux0 is equal to fx, u negative l dt is equal to ult, du over dt negative lt is equal to du over dx lt. First of all, we will substitute the equation uxt is equal to vx gt into the equation. The first ODE 1 over k gt d over dt gt is equal to negative lambda. We then can solve this equation to give us the desired equation that we want, which is d over dt gt plus lambda k gt equal to 0. For the second equation, 1 over vx d square over dx square vx 0 to lambda, we can solve the equation by multiplying both sides by vx, and then we will produce the equation d square over dx square vx plus lambda vx is equal to 0. We will move the equation lambda kg into the right hand side of the equation, which will produce dg over dt equal to negative lambda kg, and then we can solve this equation by integrating the equation 1 over g dg is equal to negative lambda k dt. The result will give us the equation ln g equal to negative lambda kt. To solve this equation, we can times both sides of the equation by exponential. The result will give us the equation g equal to exponential negative lambda kt. For vx, the equation is d square over dx square vg plus lambda vx equal to 0. Before we find the condition of vx, we can simplify the equation r equal to plus minus set negative lambda using the imaginary number general solution. Compare z equal to alpha plus iy to r equal to 0 plus I set lambda, where we will get alpha equal to 0 and y equal to set lambda. For the first case, which is lambda more than 0, r less than 0, the general solution is y equal to e power of lambda t times c1 cos negative lambda x plus c2 sinus set lambda x, where alpha is equal to 0 and the initial condition is u negative lt is equal to u lt. But notice that cos negative x is equal to cos x. Thus, c1 cos negative L set x is equal to c1 cos L set x. We then can simplify this equation into 2c2 sin L set x equal to 0. For second initial condition, du over ds negative for lambda t equal to du over dt lt, we must first differentiate the general equation of y and then substitute the initial condition. We will get the equation 2c1 sin L set lambda equal to 0. The condition is c1 is not equal to 0 and C2 also not equal to 0. Question number 1. Sin L set lambda equal to 0. We can compare it with sin n pi equal to 0, which we can deduce that lambda is equal to n pi over L square. We then can deduce that when lambda more than 0, Vx is for C2 is sin n pi x over L, which is n is equal to 1, 2 and 3. For C1, we can get the equation when lambda more than 0, Vx is equal to cos n pi x over L by comparing it with the same method. Case number 2, lambda equal to 0, r equal to plus minus square root of set negative lambda, which r equal to 0 and alpha equal to 0. The general solution is C1 e power of alpha lambda plus C2 x e power of alpha x, where alpha is equal to 0. The general solution is Vx equal to C1 plus C2x. Apply the initial condition U negative LT equal to ULT. We then can deduce that C2 is equal to 0 and Vx equal to C1. For lambda equal to 0, the solution does not exist. For case number 3, lambda less than 0, r more than 0, the general solution is Vx equal to C1 cos negative lambda x plus C2 sin negative lambda x. Apply the initial condition where U negative LT is equal to ULT. We then will get the equation given. To solve this equation, notice that cos negative s is equal to cos s, which will give the equation C1 cos negative L set L is equal to C1 cos L set negative lambda. We then can deduce that C2 is equal to 0 and C1 is also equal to 0, which give the conclusion that when lambda is less than 0, it does not exist. To finally solve this question, combine Vx and Gt together. Combine them, multiply Vx and Gt together. The product of Vx and Gt will yield to equation which is Vn sin n pi x over L e power of k n pi over L squared t, where n is equal to 1, 2 and 3. And the second equation is an cos n pi x over L e negative power of negative k n pi over L square t, where n is equal to 0, 1 and 2. Combine both of this equation together and then we will get our answer, which is UXT is equal to summation of n equals 0 to infinity an cos n pi x over L e negative k n pi over L squared t plus n power of 0 summation into infinity Tn sin n pi x over L e negative k n pi over L squared t. That's all for me. Thank you.